Good morning students, welcome to the class. My name is Deepak Kumar. In today's session we are just going to discuss BPT theorem. BPT theorem is also known as the Thales theorem, and this theorem is quite important for the students who are in their 9th class and who are in their 10th class. In addition to this theorem is quite important for the students who are preparing for the government jobs like SSC, CGL, CHSL, CPO and CDS also, okay, because the questions have been asked in competitive exams directly using this theorem. Okay, so we will discuss this theorem very deeply, and we will discuss the proof of this theorem also. So what is BPT theorem? BPT theorem says that if a line is drawn parallel to one side of the triangle to intersect other two sides at distinct points, I mean to say there is a triangle ABC, a line DE parallel to BC is drawn, and D is intersecting AB and AC at two distinct points like D and E. Okay, so what does it say? If a line is drawn parallel to one side of the triangle to intersect other two sides at distinct points, then those two sides will be divided in same ratio. I mean to say DE parallel to BC, so AD will upon BD will be equal to AE upon EC. We have to prove this. Okay, and to prove this we have done two constructions over here. One is DN perpendicular to AC is drawn, another is EM perpendicular AB is drawn, and I have mentioned over here EM perpendicular to AB and DN perpendicular to AC. This is a construction. Another construction is that B and E are joined, B and E are joined, and D and C are joined. This is the construction. These are the two constructions made over here. But I want to tell you that I'm going to provide you two different kind of methods to prove this theorem. Okay, so firstly we will discuss the proof which is written in the books and which is just produced or represented by the NCERT for the students to write in their examinations. Okay, so firstly we will discuss that proof. So we are going to move on next page. Okay, we will discuss the proof here. To prove here, I have drawn the diagram over here again. In the yellow line segments, the construction have been marked here. Okay, so the constructions were EM perpendicular to AB and DN perpendicular to AC. D and C are joined, B and E are joined, and we have to prove that AD upon BD will be equal to AE upon EC. We have to prove this. Okay, so firstly tell me, can you tell me that area of triangle ADE, area of triangle ADE, area of triangle ADE upon area of triangle DEB. As you know very well that area of triangle is always represented by 1/2 base into height. So when we are discussing about area of triangle ADE, it will be equal to 1/2 base into height. I mean to say it will be equal to 1/2. AD is working over here as base and ME is working over here as height or the altitude. In the same way, we can say that area of triangle DEB will be equal to 1/2. Here this is the base, BD is the base, and ME is the height, because here this is a triangle, BED is a triangle, and this is the vertex, and from vertex a perpendicular is drawn, but the triangle is obtuse angle triangle, so perpendicular is just meeting the opposite side outside the triangle, so we can say ME over here. Okay, so you can see that 1/2 is cancelled and ME is also cancelled, so we can say that area of triangle ADE upon area of triangle DEB will be equal to, students, AD upon BD. So this is equation number 1. Now in the same way, can we say that area of triangle can we say that students, area of triangle ADE upon now we have to take another triangle BEC, area of triangle BEC, again using the same formula, 1/2 base into height. So we can say that it will be equal to 1/2, base is AE, this time base is AE, and height is DN. upon for triangle BEC. Triangle BEC base will be EC. Base will be EC, 1 by 2 EC, and height same DN. Okay. So again 1 by 2 cancelled, DN cancelled. So we can say it will be equal to AE upon EC. AE upon EC. So we can say that understand that. Now can you tell me, students, as you know that DE parallel to BC, DE parallel to BC, okay, and between DE and BC there are two triangles are drawn. One is triangle DEB, another is DEC, है one is DEB, another triangle is DBC, one triangle is DBC. Okay, DEC. Here is triangle DEC, sorry. This triangle will be DEC. This triangle will be DEC. I have mentioned it wrong, sorry. This will be DEC. Okay. So we can say that DE parallel to BC, students. DE parallel to BC. There are two triangles. One triangle is a triangle DEC. Triangle DEC. Another triangle is triangle DEB. One is DEC, another is DEB. Area of triangle DEB. So can you say that the area of these two triangles will be equal? Area of these two triangles will be equal. Why equal? Because we have already studied that if two triangles are drawn on same base between two parallel lines, okay, if there you can see these two triangles are situated between two parallel lines DE and BC. So altitude of these two triangles will be same, okay, and the base of these two triangles is common, that is BC. So area of these two triangles will be equal, we know that. So I can say that area of triangle DEC will be equal to area of triangle DEB. So I can say that DEC can be replaced with DEB. DEC can be replaced with DEB. So I can say that this equation directly can be written as area of triangle ADE upon area of triangle DEB, area of triangle DEB, and this will be equal to again AE upon EC, and this is equation number 2. This is equation number 2. This is equation number 1. This is equation number 2. If we are gonna to compare both the equations, we can see that AD upon BD equal to area of triangle ADE upon area of triangle DEB. Here you can say that AE upon EC equal to area of triangle ADE upon area of triangle DEB. So from equation 1 and 2, I am writing right here, from equation 1 and 2, from equation 1 and 2, what do we get? We get that AD upon BD will be equal to AE upon EC. So we can say that hence proved. So this is the proof which have been mentioned in different kind of books related to 9th and 10th classes, okay, and this proof is quite important to represent while you are just gonna to write your answer sheet in your board examinations, okay. But there is also one more way, using that method we can prove this again, okay, and this second method is quite important for the students who are preparing for their government jobs, okay. So I'm just gonna to let you know the another method of proving this. So what the another method says that, okay, second method, I'm writing over here second method. To prove the second method, I'm just gonna to draw the diagram again over here, okay. So I am saying you that there is a triangle ABC, and I'm saying that DE parallel to BC, okay. In second method we don't need to do any kind of construction over here. Can I say that if, okay, I'm just directly writing the proof over here, you are saying that DE parallel to BC, if D is parallel to BC, I can say that we are talking about two triangles. One is triangle ADE, another is triangle ABC. One is triangle ADE, another is triangle ABC. So when we are saying that DE parallel to BC, So I can say that angle D will be equal to angle B. Why equal? Because these two lines are parallel and this angle will be equal to this because of the corresponding angles. Because of the corresponding angles. Okay, students. In the same way, we can say that angle E will be equal to angle C. Same. And angle A equal to angle A. This is common. Okay. So three angles of these two triangles are equal. All three angles of these two triangles are equal. Okay, corresponding angles are equal, and you know very well, if three angles of a triangle are equal to another three angles of another triangle, okay, so we can say that both those triangles will be similar triangles. Okay, similarity will be applicable over here. So we can say that triangle ADE similar to triangle ABC. Triangle ADE similar to triangle ABC. So this is the result we got over here. And what are the consequences or the results? What are the outcomes of the similarity? The outcomes of the similarity are those: if two triangles are similar, the ratio of the corresponding sides will be equal. Ratio of the corresponding sides will be equal. So we can say that, students, AD upon AB will be equal to AE upon AC. We can say that this is the outcome of the similarity. Can we say that I am just subtracting both sides from 1? I am subtracting both left hand side and right hand side from 1. So I can write here 1 minus AD upon AB equal to 1 minus AE upon AC. Now I am writing over here, we can say that by taking LCM it will become no, just a minute. Okay, this is equation number 1. Okay, we can say that AB minus AD upon AB, okay, is equal to AC minus AE upon AC. Okay, students, AB minus AD, this is AB, AD is minus, so it will become BD upon AB. And this time AC minus AE, it will become AC upon AC. EC upon AC. This is equation number 2. Now divide equation 1 by equation 2. Okay, we are dividing equation 1 by equation 2. So what will we get? AD upon AB divided by BD upon AB equal to AE upon EC upon AE upon AC. This is equation 1 na, AE upon AC, EC upon AC. So here students, AB is cancelled, here AC is cancelled, so it will become AD upon BD equal to AE upon EC. Proved. Hence proved. So first method was based on the formula of area of triangle. We proved the this BPT theorem or Thales theorem using the area of triangle, okay, concept of area of triangle. But in second method we just used the concept or the outcomes of the similarity. Okay, so this is quite simple kind of theorem and very important kind of theorem. In most of the question it is used. Okay, so please go through the videos and just share the content with others, with friends, if you are just find it beneficial for yourself. Okay, so let it spread among your friends, relatives. Okay, and thank you so much to stay with me. Thanks a lot.